Hi, I'm Chris Sciavolino, and today I'll be discussing our EMNLP paper, Simple Entity-Centric Questions Challenge Dense Retrievers, joint work with Zexuan Zhong, Jinhyuk and Danqi Chen. Many open domain question answering systems follow the retriever-reader paradigm, which splits the task into two steps. First, the system uses a retriever to select a small set of candidate documents deemed relevant to the question. Second, a neural reading comprehension system parses the candidates and returns the most likely answer. For this work, we focus on the document retrieval step of this pipeline. Many early systems relied on sparse retrieval models like TF-IDF or BM25, which are very good at capturing lexical overlap, but cannot encode semantic information. In the example below, the question, "What is the smallest penguin species?" has many overlapping words with the gold passage, yielding a high BM25 score. On the other hand, the question, "Who is the bad guy in Lord of the Rings?" is difficult for sparse models, as the term antagonist in the gold passage is semantically identical but lexically distinct from bad guy. More recently, dense retrieval models have exploded in popularity. Dense retrievers leverage large pre-trained language models like BERT to encode semantic information into short, dense vectors. Since BERT does a great job of encoding semantic information, dense retrieval models can better represent questions like who is the bad guy in Lord of the Rings. However, since it does not explicitly model tokens in the text, they are not as strong at capturing lexical overlap. Many recent papers, including dense passage retriever, denoted DPR here, have demonstrated that dense models far surpass sparse models on many open domain QA benchmarks like natural questions and trivia QA, leading to many systems completely replacing their sparse model with a dense model. However, we were curious about how DPR would generalize to new types of questions. We constructed a dataset from Wikidata where each triple was converted to a question using the manual template, "Where was E born?", where E is the name of the subject entity. Even though this question is very simple and one of the most common relations in Wikidata, we found that DPR significantly underperforms BM25 on the dataset, by nearly 50% in this case. Based on this idea, we extended the dataset to 24 common relations from Wikidata, creating a question template for each. The key thrust of our new dataset, EntityQuestions, is to focus on simple questions about a diverse set of specific entities. We found that across all 24 relations in our EntityQuestions benchmark, DPR trained on NQ lags behind BM25 by 22% on average. While training on more datasets, as in DPR multi does help, it still lands far behind the sparse baseline. Along with presenting this dataset, the main goal of our paper was to figure out why. Why does DPR, which significantly outperforms BM25 on most open domain QA benchmarks, fall so short on these simple questions? Specifically, we had two main questions. One, how does the specific entity affect DPR's performance? And two, if the model sees the question pattern during training, is it able to generalize to new, unseen entities? For the first question, we find that the entity chosen deeply affects the retrieval performance. The accuracy of the sparse BM25 model is relatively invariant to how common the entity occurs in Wikipedia. However, DPR is much more likely to correctly answer questions about more common entities than questions with less common entities. When we consider questions about entities observed in the NQ training set, we find that DPR performs better for some relations like place of birth, but not across all relations. As for the second question, we want to test whether observing the question pattern with one set of entities can help the model generalize to new, unseen entities at test time. We find that indeed it can. When we fine-tune both the question and the passage encoder on questions with a disjoint set of entities, we find that the fine-tuned model can match or exceed the sparse model. In fact, if we train on a lexically different but semantically equivalent template, we still observe the same trend, which demonstrates that DPR is not simply overfitting to the question pattern. More interestingly, we find that specifically the passage encoder is crucial for the performance improvement observed. We consider two training setups. The first, called only Q training, denotes only updating the question encoder and keeping the passage encoder weights fixed during fine-tuning. Conversely, we also consider only P training, where we only update the passage encoder and keep the question encoder fixed during fine-tuning. We observe that while only Q fine-tuning improves performance moderately, only P fine-tuning improves performance significantly more, implying that updating the passage encoder is more important for this task. To further study this phenomenon, we visualized positive passages from NQ and place of birth questions using TSNE before and after fine-tuning both encoders. Before fine-tuning, we see that positive passages for place of birth questions are highly clustered together in one part of the space. After fine-tuning, we see the positive passages for place of birth questions are better distributed. We hypothesize this dispersion better allows the model to differentiate between passages about similar entities. Now that we have a good idea of the problems with DPR, we explore some potential solutions to fix these issues. First, we consider data augmentation as a simple solution to the problem. Second, we explore the idea of specialized question encoders trained using a single fixed passage index. For data augmentation, we consider simply adding another fine-tuning step using questions from EntityQ. We see clear gains on the in-domain relation, as well as on EntityQ on average. However, it comes at the cost of significant degradation on the original domain, natural questions. Next, we instead add some EntityQ samples to the original training set and fine-tune on both the original training set and additional EntityQ questions. We observe that these models retain most of the performance on NQ, but see limited gains on the new domain and on EntityQuestions on average. Clearly, it doesn't seem that simple data augmentation will do the trick. Next, we consider specialized question encoders, where we use a fixed passage index and fine-tune lightweight question encoders using only Q training. We first note that the choice of passage index matters a lot. A DPR model trained on a small subset of the probably asked questions denoted PAQ dataset is much better than the model trained on NQ at EntityQuestions out of the box. We also find that using a single specialized question encoder for each relation achieves very promising results on average, with the DPR model trained on PAQ nearly matching the sparse baseline. Finally, we note the individual per-relation question encoder approach surpasses a single encoder trained on all of the relations, implying that each encoder captures different and distinct information. In conclusion, we find that dense models struggle on entity questions, our benchmark of simple entity-centric questions. We observe that dense models exhibit a popularity bias, performing much better for common entities compared to less common entities. We also find that adapting the passage encoder is crucial for generalization. Finally, we find that data augmentation is not a sufficient solution to solve this problem. We also believe that building a robust passage space with specialized question encoders is a very promising new direction for future research. We would also like to highlight two larger directions for future work. First, leveraging explicit entity memory during the retrieval step could help incorporate better entity information. Second, a hybrid approach of both dense and sparse retrieval systems could also help the model generalize to new distributions. You can find our dataset and code at the GitHub link here. Feel free to open an issue or contact us if you have any questions. Thank you.